Page 13 of Logic. Number 7. Use the truth table to analyze this argument. So the inputs are P and Q, and we're going to put 2 trues and then 2 falses for P, and then we're going to alternate true-false for Q. That's every single combination possible. Then we're going to start building this argument. So we'll start with the left side. To build this argument, we need a P or Q. P or Q is true whenever there's like one true. So the first 3 are true because they have at least one true, and then the double false at the end is going to be false. Then we want to make the not P or Q in parentheses, and then we just invert everything. So the trues become false and the false becomes true. Okay, now we're going to build the second side, which is this. So we need a not P and we need a not Q. Not P, not Q. And we'll just invert everything for P. It's false, false, true, true. And then we invert Q. It's going to be false, true, false, true. And then we're going to OR those together. We're going to OR these two. And when we OR it together, we get false, false gives false. False, true gives true. True, false gives true. And true, true gives true when we OR those together. Okay? And then we're going to check the implication. So what are we implicating? We are going to start with this, and we're going to see if that implicates this. Okay, so let's see. So if this is true, then this is true, and that's good for implication. For implication, we want, whenever this is true, we want this to be true too. And so, but when this is false, then it doesn't matter what happens with this. It could be true or false. So that's pretty much what we have, right? Like when it's true, so that's good. When it's false or true, which is fine too. So everything is true, and this argument is valid. Okay, if you get tautology at the end, then the argument is valid. Use a truth table to analyze this argument. Okay, so we're gonna we start with P and Q, and then we're gonna need a P or Q, and then we're gonna need something similar to that. So how about we just copy and paste the first 3 columns because they're exactly the same. Copy, paste. Okay, and then we'll move on. We're going to put not P and not Q. So we'll do not P, not Q here, and it's just everything inverted, right? True becomes false. Q becomes not Q. Okay. And then we are going to AND together not P and not Q. So not P and with not Q. And that would be a false, false is false. Only the 2 trues give you a true in this case because it's an AND. The rest is false. Okay. And then we're going to check oh, I forgot to do one more thing. I didn't do not P or Q, did I? I should have just copied and pasted that. How about if I move this over? Move that over. And then now I'm going to copy not P or Q. This one here. Copy, paste. Okay, oops. Okay, so for the implication, we are seeing if this implies this. Okay, so we have the when the left side is true, the right side is true. So that's good. That's valid. When the left side is false, which is the other three cases, the right side is false, but it doesn't really matter what it is. We accept anything. Okay? Because like whenever this is true, we want this to be true. When this is false, we don't care what it is. It could be true or false. Both of these are valid. Okay? So, this is a tautology, so that is also a valid argument. All right. 9J. Write each of these arguments in symbols and then test its validity. So let's see. If Ayla plugs the DVD player in, it will blow a fuse. Okay. So we'll say that plugs the DVD player in is P, and will blow a fuse is Q. Okay. So if P, then Q. If she does not plug the DVD player in, she does not plug the DVD player in, therefore it will not blow a fuse. So the way you'd write that is first the fact that P implies Q. Plugs the DVD in, it'll blow a fuse. Then you're going to AND it with the fact that she did not plug the DVD player in, so it's not P. Then it says that leads to the fact that it will not blow a fuse. And we're wondering if that's true. Okay, so we're just going to build this thing. And so first we're going to use this, and then we're going to use this. And you can see how we use PEMDAS here. It's just like we gradually include more and more stuff. So we'll start with P and Q, just like we did up top. 2 trues, 2 falses, true, false, true, false. And so then we'll do like P implies Q. If P, then Q. Then the 2 trues is fine. The true leading to a false is not fine because implication means that whenever P is true, Q has to be true also. And the other two, it doesn't matter because P is false. Anything goes. Okay? And then I'm going to AND it with not P. And remember, not P would be just, false, false, true, true, right? False, false, true, true. And so I'm going to AND this and this. I'm going to AND it together. And that's going to give me false, false, true, true. The last two are going to be true because they're double trues. Okay, so that was the left side. We finished the left side. Then it says the left side implies not Q. Well, what's not Q? Not Q is false, true, false, true. Okay, and then let's check. Does this imply this? And so let's see. Does false lead to false? Well, when the left side is false, we don't care what happens to the right side. So if the left side is false, everything is true. What about when the left side is true? We expect the right side to be true also. So this is okay, but this is invalid. Okay. So let's see. Let's check again. So if she plugs in the DVD player, it'll blow a fuse. And then we AND that with the fact that the DVD player is not plugged in, and then we're going to check to see if that implies that it won't blow a fuse. And no, there's one case where it will blow a fuse anyway. Okay, so this is not invalid. Okay. Number 3. Isaac will pass the math test or drop out of IB Diploma. So we'll pass the math test. We'll assign that variable P. Drop out of the IB Diploma, that'll be Q. So it's saying Isaac will pass math or he'll drop out of the diploma. He does not drop out of the diploma. So let's see, we're going to AND that with no, he didn't drop out. Therefore, he passed math. So passed math will be that. Okay, let's see if that's true. So first we'll make P and Q our input values, and we'll start out with true, true, false, false, and true, false, true, false. And then we're going to find not Q. Not Q, which is the inverse of the previous column. Okay, and then we're going to AND together. Oh, we haven't done P or Q yet. So we're going to have P or Q. P or Q is only true every time you see one true, at least one or two true. So those are all true, and then the last one is double false, so it's false. And then we're going to AND this together with this, okay? And when we do that, we're going to get the whole left side, which is this, okay? And if we AND it together, the only time it's going to be true is when it's a double true. Everything else is false. Okay, and then we're going to see if that implies P. Now P is we're going to rewrite P here just so that it's easier to see. P, remember, is true, true, false, false. So does this imply P? Well, if true implies true, that's a good sign. That's true. When it's false, we don't care what happens with P. So anything goes. So yeah, all these are true also. So hey, look, it actually implies P. So this what do you call it? The argument is valid. Okay? Yes, it's valid. All right. Number 5. If a person has an annual medical, then many illnesses can be detected early. Okay, so if he has an annual medical, many illnesses can be detected early. They'll call that Q. If illnesses are detected early, that's Q, then many lives can be saved. That's R. Therefore, if people do not have annual medical, many lives will not be saved. Okay, if people do not have annual medical, so that would be not P. Many lives will not be saved. So therefore, many lives will not be saved. That would be not R, right? Not R. Okay. So we'll write this out. If annual medical, many illnesses can be detected early. Okay, and then and we're going to AND that with illnesses are detected early, then many lives can be saved. Okay. Therefore, so after all that, we're going to say therefore, if people do not have an annual medical, let's see, if people do not have an annual medical, then not P implies not R. So first I'm going to start out with the inputs, which are P, Q, and R. I'm going to put every single possibility. So first I'm going to put 4 T's, and then I'm going to put 4 F's, and the next column I'm going to put 2 T's, 2 F's, 2 T's, 2 F's, and then for R I'm going to put TF, 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 TF. And then I'm going to start building this argument. So the first thing I'm going to build is P implies Q. Okay, let's see. If it's P implies Q, that means when P is true, then Q has to be true also. So that's fine here. That's fine here. Uh-oh. Every other true, it's false, so that's not good. Now when P is false, it doesn't, when P is false, Q can be anything, so the rest of it is all true. Okay? And then we're going to do this one here. Q implies R. This is probably going to be kind of similar. Q implies R. Q implies R. So when Q is true, then R should also be true, and that's okay there. And it's also okay there. Every other place that Q is true, it looks like R is false, so we want to make those false. So this would be false, and this would be false also. Now the places where Q is true, or when Q is false, then R can be anything it wants. So anywhere where Q is false, we just mark it true. All right, and then we're going to and together this and this. When we and these together, only the double trues are true, and there's only a few of those. Okay, and then everything else is false. So false, 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 and false. And this is the whole left side, so it's like the parentheses and parentheses thing. Okay, that's the left side. And then we're going to we're going to build the right side. So we're going to say, okay, not P and not R. So not P is just the inverse of P, so the first four are false and the last four are true. And the not R is the inverse of R, so it's just false, true, false, true, false, true, false, true. Okay, now we're done with that. And then we're going to finish with the right side, which says that not P implies not R. Okay, let's see if that's true. Okay, so whenever not P is true, which is the bottom four places, then not R also has to be true. That happens in these two, but the other places it's false, so that's not good. Okay, now what when not P is all false? Well, then it doesn't matter what not R is, so they're all true. Okay, because we don't care what happens when not P is false. Okay, so that and so this is actually not P implies not R. Okay, we just built that, and so this is actually the let's see. So the left side is represented by this column, and the right side is represented by this column. And so we're going to see, does orange imply pink? Okay, so whenever orange is true, then pink should be true also, and when it is, we're going to mark it T. Uh-oh, look at that. Orange is true, but pink is false. That's not good. There we go again. Orange is true, pink is false. Oh, here we go. Here's a good one. Okay, now when orange is false, it doesn't matter what pink is. So whenever orange is false, everything's true. Okay, and so this is the orange implies pink. Okay, so it's like the entire expression. And there's a couple times that it's false. So this is not valid, invalid. Okay, now let's move on to number 7. Is this the last one? Oh my gosh, the last one. It's a big one. Maybe the biggest one we're going to do. If Dr. Underwood gives difficult tests, then the students will fail. So we'll say Dr. Underwood gives difficult tests, that'll be P. Students will fail will be Q. If the students fail, which is Q, then they will complain to Miss Smart, which is R. If they complain to Miss Smart, which is R, then Dr. Underwood will be dismissed. We'll say that's S, okay? Therefore, since he was not dismissed, he must give easy tests. He was not dismissed, so that would be not S, and easy test would be the opposite of P, so that would be not P, okay? All right, now let's try to write the whole thing. So if Underwood gives difficult tests, then the students will fail. If the students fail, then they will complain to Miss Smart. Q implies R. If they complain to Miss Smart, R implies S, then Dr. Underwood will be dismissed. If they complain to Miss Smart, Dr. Underwood will be dismissed, which is S. Okay. Therefore, let's see, since he was not dismissed, not S, then he must give easy tests. So the reason why this is so giant is this is our first time with 4 inputs, P, Q, R, and S. And the philosophy is still the same. First thing you're going to do is you're going to fill up half the table with truths for P. And then you're going to fill up the rest with. Then for Q, you're going to alternate 4 truths, then 4 falses, 4 truths, then 4 falses. And then for R, you're going to alternate 2 truths, then 2 falses. And you can see I was short one line, one row in this. And finally, S is just going to be alternating true, false, true, false. And you can see we did this in a really organized way, so we can easily see that every single possible pattern of true, false is represented here for PQRS. Okay. The next thing we're going to do is we're going to start building the statement. So the first thing we want to draw, I guess, is P implies Q. So P implies Q. So whenever P is true and Q is also true, then that's good. Okay? But when P is true and Q is false, then that's invalid. Because this is basically saying when P is true, Q has to be true too. When P is false, Q can be anything. So then these are all false. Oh, I'm sorry, they're all true. True, 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 true. Okay. Okay, and then Q implies R. This one here is the next thing we're going to build. Q implies R. So Q implies R. We do the same thing. Whenever Q is true, which is the first 4 of them, then R should also be true, but of course they're not. So only when they're both true, I mark it true. And that happens down here too, right? And that's it. Otherwise, the places where Q is true, R is false. So we mark those false. And then any place Q is false, then it's fine. R can be anything you want it to be. So we can mark the false places true, right? Because that's fine. Whenever Q is false, it doesn't matter what R is anymore. Okay. So that was Q implies R. Now the next thing would be R implies S. R implies S. So we do the same thing again. Whenever R is true and S is true, then we mark it true. So let's mark the R and S whenever it's true. There's true there, double true there, double true there, double true there. Okay, so we'll mark all these true. And then also, whenever R is false, it also does not matter what S is. So we can mark all of these true also. So when R is false, S can be true or false, and it's valid. So we'll just mark all those true also. Okay, that's quite a bit. And then what's left, we mark false. Okay. And now we're going to do the left side of the equation. The left side of the equation basically is a triple and of the 3 implications that we did so far. So, and a triple and is going to be true if all 3 things are true. So let's say, okay, so we have 3 truths there, we have 3 truths there, we have 3 truths there, and we have 3 truths there, and we have 3 truths there. So now all these will be true, and then everything else will be false. False, 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 false. Okay, that's the left side. Now we're going to map out the right side. First, we're going to make a not S and a not P, because those will come in handy. So not S, not P, and we're going to draw all those out. So not S would be false, true, 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 false, true. Okay, and not P would be, the first ones would be false, all the way down to the 8th one, I think. And then the remaining 8 would be all true. Okay, and then I'm going to combine those, not S and not P, using implication. So not S implies not P. And we'll see if that works. Okay, not S implies not P is true as long as there is a double true. So let's see if there's any double truths. Here's one, and here's one. So there's two double truths. The implication is true for those two cases. Whenever not S is false, it's also fine. We don't care what not P is when not S is false. So everything that's false, we'll go ahead and mark it true also. Because then it doesn't matter if S happens or not. Oh, here's another double T. There's another double T. Okay? So let's see. Oh, and there's another double T. Kind of careless, huh? Okay. Now, true falses, those are false because that means that the implication didn't work. The left side was true, but the right side still didn't happen. Okay, so there's a few that are false. Okay, now that is the right side. This was the right side. So we have the left side and the right side. And now we need to see, does the left side imply the right side? Okay, now we're going to compare this. We're going to say, does this imply this? Okay, so if there's double truths, then we put truths there because that means the left side implied the right side. Yes, yes, yes. Now, if the left side is false, then we also mark that true because if the left side is false, we don't care what happens with the right side. Anything can happen. Okay, wow, look at that. It's what we call a tautology. And if we have shown that the left side always implies the right side, then the statement is valid. So finally we get a valid one. And that's it.